Hey everybody, I'm Michael Hall, a developer evangelist here at ARM. And with me today, I have Julien Simon from Arcee AI, and we're going to talk about the latest developments in small language models and edge AI. Julien, welcome to the show. How are you?
I'm very good. Thank you for having me. Thank you.
So, to start off with, why don't you give us a little bit of background about what Arcee is and what it is that you do?
Sure. So RCAI is a US startup. It's about 2 years old, and long story short, we specialize in small language models. So the company started by um, strengthening, improving the best open source models available on Hugging Face, running them through our post training stack with techniques like model merging, model distillation, et cetera, on high quality data sets that we built. And so we shared those models back, and then they always took the top spot on Hugging Face. We also built some custom models for industry customers. And as of a few weeks ago, we're now officially a foundation model builder. We have the first model in a new family of models that we call AFM RC Foundation models. And the first release is a 4.5 billion parameter model that we trained from scratch. So it's a new architecture, and it's trained on completely clean, curated data that we put together. So very excited about this first step. And we're joining a very small club of, I would say, foundation model companies, and it's the first of many other models. So that's the whirlwind tour of RC right now.
Very good. Now, I think most people watching this probably know about large language models. They're familiar with the Chat GPTs, the Llamas, the Gemmas. What is a small language model?
So that's a great question. It's not that simple, actually. I mean, we could go for 2 hours on, okay, what's the size, right? I mean, how small is small, and what's the threshold? Um, my simple answer to this is, if we assume that the GPTs and the Anthropics of the world are trillion sized, trillion parameter size or something, then small language models are just a few percent of that. So I would say if you're working with a 30 billion or less, you're working with the small language models. I used to say, if it's small enough to run on a mid-size or entry-size accelerator, it's a small language model. If it's small enough to run on your laptop, it's a small language model. So that's kind of, if we talk about the size, that's really what we see.
Okay. And how do you take a large language model and turn that into a small language model? Like, what is the process of shrinking that?
So, so actually, again, a very interesting question. So generally, small language models are, I would say, net new architectures, right? So they start, the model builders like Google or Meta or Quen, Alibaba, etc., or us. We start from a net new model architecture. So a specific way to organize those neural networks, right? And then you train, and that's just a blueprint, right? The architecture is just, it's blank, right? So you need to train the model on a fairly large quantity of data and natural language, and hopefully different languages, and code, and unstructured data of any kind, and then you come up with a model. So for a long time, small language models, as the ones available on Hugging Face, have been trained in a completely different way. But your question actually is very relevant, because now, using techniques like distillation, we can actually distill knowledge from the much larger models, like GPT-4 or DeepSeek R1, and we can use that knowledge to train the small language models. So it's a kind of a teacher-student kind of thing, right? Um, Ask the large model some questions, look at the answers, and now those questions and answers, they're a data set you can use for training. So you're literally teaching the little guy to behave or mimic just the behavior of the larger model. So there is a connection, but I would say generally, it's the techniques are very different. The costs involved are very different. The infrastructure required to do that is very different. But through distillation, you can hack your way into some of the knowledge of those bigger models.
Okay. And do you also use processes like quantization? That's a big thing I know here at ARM to
Oh
reduce
yes.
sizes.
So the models, I keep saying the small language models are getting smaller and smaller, yet they get better and better, right?
Mhm.
So with parameter size, model size, parameter count are one indication of okay how powerful, how knowledgeable a model is going to be, but that data point rots very quickly, right? I mean, a 70 billion parameter model from 6 months ago is going to get crushed by maybe an 8 billion parameter model today because the training techniques have improved, because the data quality has gone up. So don't think that parameter count is a lasting indication of how great the model is. It's very, very volatile. Um, so the great thing about this is now the models are getting so small. We have amazing models below 10 billion parameters, and the first foundation model that we released is actually a 4.5 billion. And yet it outperforms much bigger models, like I said, but they're getting so small, like single digit billion parameters, that now you can run them very, very efficiently, not only on very small, GPUs, but also on CPU platforms. And through quantization, you can shrink them just a little bit more. Um, so obviously, less, I guess, less memory pressure on the host running the model, but more importantly, you can quantize the models to integer weights, and you can leverage instruction sets that ARM CPUs, for example, support for acceleration. So it's an alignment of planets. It's models getting really small, yet really better than even the bigger models from a year ago. It's the quantization that helps us move from floating point arithmetic to integer arithmetic, and it's the cool instruction sets on modern CPUs like Neoverse, etc. That help accelerate integer arithmetic, and those things line up perfectly, and that's what makes it possible to take those models and run them at very, I was going to say very decent speeds, but it's more than decent actually. Sometimes it's impressive speed on modern CPUs.
That's really cool. And that opens up new use cases, right? It's
Sure.
not, AI isn't just something that you call out to a service with anymore. What are the kind of things that you see people doing with Arcee's models?
So I would say generally, I mean, our model are general purpose generative AI models. So all the use cases you can think of are supported. Our customers still rely heavily on, I would say, text generation, some image to text generation, but in the enterprise world, it's still very much about text generation. So chatbots, knowledge bases, document processing, you name it, right?
Mm-hmm.
So if they have very large scale, then of course GPUs are the reasonable choice. But with the rise specifically of agentic workflows, customers realize that not one single model is going to rule them all. You can't just have the Swiss Army knife LLM that works for everything, because first of all, it doesn't work for everything, and it's huge, it's expensive, it's slow, and if you need 9 model steps in your workflow, that just doesn't work. So instead, they try to work with a galaxy of smaller models, so small language models that have possibly been tailored for the particular task at hand. Okay, And so that now you really don't need to run those models on big fancy accelerators, especially if you're running agentic at scale. You could scale in and scale out on CPU and get really good results. How do you run 100 workflows in parallel, and then at night maybe you run one or two. If you leave that GPU instance on 24/7, you're paying for idle all the time. But if you're scaling in and scaling out on CPU, you could have 60 instances during peak time and one at night, costing you nothing. And that's just the cloud. And then obviously there's all the edge use cases, or the on-prem use cases, or even the device use cases where GPUs are maybe too expensive for or not delivering ROI. Maybe they're not even available. Maybe they make no sense, right? I mean, if you have 1,000 restaurants across, let's say, the US, are you going to deploy 1,000 GPU servers at the edge? I don't think so.
No.
And on device is obvious, right? It's just you use what you have on the device. So and it's 99% of the time it's going to be ARM based. So the fact again that we can work with small models, optimize them, make them really great in terms of business quality, and run them efficiently on smaller platforms, possibly very far away from the cloud, is opening up a lot of discussions.
And you did some benchmarking of running your models on CPU on AWS. And I wanted to talk about that because there's some amazing numbers that you mentioned in your blog post about this when you did that comparison to x86.
Yep. And to be fair, and full disclosure, I worked for AWS a little while ago for 6 years. So yes, I did run those numbers on AWS because that's what I know and I'm comfortable with. But to be fair to other players, I also ran them on on Google Cloud, on the Axion CPU. And as soon as I get my hands on those, I will run them on the Azure ARM instances as well, right? And long story short, the numbers are the same everywhere. So nobody's really leading here. It's just it's a good CPU. It's available across clouds, and you'll get good performance everywhere. It's pretty impressive what you can get. And again, like I said, the alignment of small models, ML engineering, quantization, very good inference servers. Llama CPP is my personal favorite, but there are others. And the hardware acceleration works well, and you can run, depending on the model. The 4.5 billion model that I tested, I got something like 60, 70, 80 tokens per second. So token is, to keep it simple, is roughly equivalent to a word. Okay. So you can be generating at, let's say, 40, 50 words per second, which is way faster than anybody can read, and which is way faster than what you're getting with the ChatGPTs of the world.
Mm-hmm.
And generally, anything above 10 words per second is considered okay.
Right.
It doesn't give you that, one word at a time feeling where it's like, oh no, this is way too slow.
Yeah, as long as it's faster than you read, then that's as fast as you need.
Yeah, and so for conversation, it's okay. I would say, I use a lot of code generation, and code generation should be faster than that, because you tend to generate longer bits of code, and you probably want a little more than 10 words per second. But the fact that you're getting 40 or 50 or 60 is, as you said, it's too fast for a single user, which brings me to, you can actually serve multiple users, right? And we refer to this as, batch size. So batch size 1 is the CPU is just predicting one request at a time, not multiple requests at a time. But if you go batch size 2, batch size 4, then you can, you can batch prompts coming from different users, and you can optimize for throughput. and you can keep the hardware busy all the time. And of course, not everybody's going to get 50 tokens per second. Maybe they're going to get 10 or 12. But as we said, it's enough.
Okay.
And so that means that with a single CPU, you all of a sudden you can serve 4 concurrent users, or 4 different apps, et cetera, et cetera. And of course, they're not all busy all the time. So again, the ROI goes up, right? And that's a consequence of just smaller models on better hardware with good inference servers, and so it's just giving organization more flexibility to say, well, do I really need a GPU for this one, or is it small scale enough, right?
Right.
That I can consider CPU performance, which will be slower than GPU. I mean, no doubt about it. But it's also going to be much more cost effective and much more easier to procure, right? Try getting many GPU instances from your favorite cloud. See what they tell you. Go ask them for a lot of Graviton instances on AWS. They'll say, oh yeah, how many do you need?
As much of those as you want.
and they can optimize them as well, right? Then they have all those commercial deals like reserved instances on AWS, where if you commit to a certain spend for a year or something, you get a crazy discount. And it's a volume play, right? So if you ask them for 2 GPU instances, you're never going to get that. If you ask them for 50 Graviton instances, of course you're going to get that. So, the snowballing effect is, in terms of improving ROI, is very interesting. But you have to do the exercise. You have to go beyond the basic reaction of, oh, of course CPU is slower than GPU. It's never going to work. It's not the point. It needs to be fast enough, right? So decide what fast enough means to you and your use case, and then of course look at ROI, right? Because super fast but super expensive means nothing to your to organization. There is such a thing as too fast
for the
and
cost
too
of one
expensive.
GPU, then that scales a lot easier.
Exactly.
So I wanted to give you a chance to talk about Conductor and Orchestra, because you talked earlier about how people want to use multiple agentic AI models now at the same time. So how do you work all of those things together into a single product?
So Conductor was born from customer discussions, and customers told us, okay, yeah, we get the Swiss Army knife analogy. Okay, we know we can't do everything efficiently and well enough with OpenAI or whoever, and we get SLMs. Okay. And we have 1.8 million models on Hugging Face, and we cherry-picked maybe 10 of them or 5 of them, and we fine-tune them for different use cases. Okay, so now we have 10, 20, 30 models, and we know which one to use for what prompt, right? For which prompt, but can we do this dynamically? So in other words, can we just offload that decision and to a platform, and can we just send a prompt to a model router that will analyze the prompt, look at the domain, look at the complexity, and a few more things, and then in real time decide that, okay, this should go to this model or that model, or maybe, because it is a very, very complicated prompt, it does require, GPT-4, or it does require Anthropic, etc. And that, in a nutshell, that's what Conductor is. It's a model routing platform. So we train the router to go and work with our collection of small language models, and it tries to optimize for that most of the time, because they're smaller, so they're faster, and obviously much more cost effective. But from time to time, yes, there is a crazy complex prompt, and that one needs to go to a much larger model. So we send it to an LLM, which is going to be more expensive, very, 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 very much more expensive.
Right, but if it's only a few prompts that are going there, then
few,
that's
right?
a huge
So
cost
it's money. Hopefully, it's money well spent. That's how I would put it. It's like you're getting more bang for your buck and you're only spending more when it's required and when it makes sense. So that's a really interesting interesting product. And it would be possible for customers to add their own custom models to it if they wanted to. So that's model routing. For agents, so we had a first version of an agency platform called Orchestra, where we try to build a graphical drag and drop kind of platform, helping customers design workflows through that interface, and then publish workflows and interact with workflows. We got some success. We got some customers, but in typical startup fashion,
Sure.
we've decided to reboot it. We think we went a little too crazy on it, and it's still a little too complicated. And we got great customer feedback on what we should be building next, and we are building it right now. So there's going to be a new version of Orchestra, soon, and it's going to be a little different. But it's going to be much simpler, and we hope it's going to be more powerful and just easier to use for customers.
I look forward to seeing that. I also look forward to seeing how much faster your models will run on new ARM CPUs that have the SME2 instruction set in them, because I've heard some impressive acceleration numbers from that is just automatic using frameworks like Llama CPP.
Yeah.
So that looking forward.
I want to say. I want to congratulate ARM for actually contributing to those projects, and specifically to Llama CPP, where your teams have contributed the so-called kernels, so the very highly optimized math routines that Llama CPP uses for inference and leveraging the instruction sets, etc. I mean, you're in the best position to do this, right? And the community is awesome, right? The community would have done it, okay? But I think it's better when it comes from the manufacturer, because best. I mean, you have early access to your own chips and the new ones, and you're in the best position to contribute to that. And generally, I always want to congratulate large tech companies for supporting open source projects and contributing. So I hope to see more of that, and I wish more companies did that. I think it's very important. All those small language models are open weights. Again, Hugging Face is doing very good work. We have really cool projects out there. VLLM, Llama CPP, and we always encourage customers to build with open source. So I think it's the best way to build. It's what preserves their investment better over the long term. But this is not possible unless we have contributions from tech companies. So thank you, ARM, for doing that.
Absolutely. I mean, we're part of this community. We're part of the AI ecosystem. So it's great that we can contribute back to these projects because they're open source.
Yep.
Well, Julien, thank you so much for being on the show. Before we wrap things up, as a developer, how can people find out more about Arcee and your models and how to start using them in their own applications?
So I'm actually, so you can always go to our website, arcee.ai. You can look me up on GitHub and YouTube and everywhere. I'm easy to find. It's my job, I guess, to be visible and easy to find. And I'm always happy to connect and answer questions. In the next few weeks, and by the time you're watching this, it's quite likely, they may be out. I'm actually writing a couple of learning paths for on the ARM website to walk you through deploying and optimizing our 4.5 billion parameter model on AWS Graviton and on Google Axion. Okay, so I'm still finalizing those. I got some feedback from the team, so going through the final last tweaks. But these will be, I think, if you're new to small language model inference on ARM, these will be excellent entry points. So go and look for the Arcee learning paths. Hopefully they'll be out in in a couple of weeks.
Fantastic. I'll make
and you
sure
can
that
take
we
it from
get
there.
those links down in the description.
Yeah, sure. That'd be great. Thank you very much.
All right. Thank you again, Julien. It's great to have you on, and look
Thank
forward
you.
to seeing what Arcee is doing in the future.
Oh yeah, watch us.
All right. Take care.